All right, today we're jumping into something that is absolutely crucial for managing any successful application in Azure, monitoring your load balancer. Because look, it's one thing to build it, but you really need to understand what it's doing. So let's dive right in.
Okay, so let's picture this. You've built an amazing app. People absolutely love it. Users are just flooding in. I mean, that's the dream, isn't it? But with that kind of success comes a brand new, very real problem.
Because that tidal wave of users, it can just crush a single server. And suddenly you're looking at super slow load times, or, let's be honest, the whole thing just crashes. The very thing you wanted, all that success, is now putting your app stability at risk. So, what do you do? Well, that's where the load balancer comes in. Just think of it like the perfect digital traffic cop for your application. Its whole job, its entire reason for being, is to take all that incoming traffic and intelligently spread it out across your different servers. That way, no single server gets completely overwhelmed. Okay, that's the concept. But what does a setup like this actually look like inside Azure? Let's pull back the curtain and check out the blueprint.
So here it is, the whole shebang. Everything lives inside this one virtual network, or VNet, as you'll hear it called. You can see our workhorse servers, VM1, VM2, and VM3, tucked away in the backend subnet. That's where the real work gets done. And then, right out front, playing the role of the director, is our load balancer, aptly named My Entone Load Balancer.
Now, I know this might look a little complicated, but building it is actually more straightforward than you might think. We can really just break the whole process down into a few key logical steps. So, step 1, you create the container for everything. That's your virtual network. Step 2, you define the load balancer itself. Then, step 3 is where you give it the rulebook. The health probes to keep an eye on your servers and the rules for where to send traffic. And finally, you just tell it which servers are on its team. All right, let's dive a little deeper into the setup. The very first thing you've got to do is define what's called the backend pool. Seriously, just think of it like you're picking players for a team. This is the group of servers, your virtual machines, that are going to work together to handle all that incoming traffic. But here's a good question. How does the load balancer know if a server is actually healthy and ready to take on work? Well, that's where health probes come in. They're like these little automated checkups. They constantly ping the servers at a regular interval just to ask, hey, you still good? You alive and well? And if a server ever fails that health check, boom, the load balancer instantly knows to stop sending traffic its way. And this right here, this is the real brains of the whole operation, the load balancing rules. These rules are what tie everything together. A rule connects the front-end IP address to that team of servers in the back-end pool, and it uses the health probe information to know which of those servers are actually available. This is the logic that decides exactly how a user's request gets routed to a healthy, waiting server. Okay, so we've built it, we've set all the rules, but the big question is, did it actually work? I mean, how do we know for sure? Well, it's time to put it to the test. And you know what? The test is actually surprisingly simple. All you do is hop on a test machine inside your network, browse to the load balancer's IP address, and just start hitting that refresh button over and over. And just like the source material points out, if you see the page responding from different servers each time, you know it's working. The load is being distributed. Success! But look, knowing it works is just the beginning. A simple pass or fail test isn't where the story ends. The real power, the real game changer, is when you start monitoring the system over time. That's how you get those deep insights. This is the real payoff. So, the system's up and running. It's balancing traffic. Awesome. But is it working well? Is it efficient? Is it truly healthy? Are there hidden bottlenecks that you just can't see? To answer any of those questions, you need one thing: data. And your starting point for that data is going to be Azure Monitor. Specifically, you'll want to check out the Insights dashboard. This thing gives you an instant, at-a-glance view of all the key metrics, stuff like connection counts, health probe status. Just think of it as your command center, that high-level 30,000-foot view of your system's overall health. Now, when you need to go deeper, you click into the detailed metrics. Right away, this overview answers two absolutely critical questions. Number 1, is the load balancer even online and available? And number 2, how much data is actually passing through this thing? Then you've got the Data Throughput tab, and this is where you can really start to feel the pulse of your application. This chart literally shows you the ebb and flow of data over time. You can see exactly when your peak traffic hours are and how much data the load balancer is juggling at any given moment. This is absolutely crucial for planning your capacity and spotting any weird, unexpected traffic spikes.
And this brings us right back to the million-dollar question. Is the load actually being balanced? Well, the flow distribution view answers that perfectly. It breaks down the traffic flow to each and every virtual machine on your team. Because if you see one server doing way more work than the others, well, that's a huge red flag. That's a bottleneck just waiting to cause problems. And it kind of defeats the whole purpose of having a load balancer in the first place.
Look, performance metrics like data throughput are super important, don't get me wrong, but they're really only half the story. The other half, which you could argue is even more critical, is the overall health and availability of your resources. And the resource health page is the perfect place to see this in action. What's so great about it is that it doesn't just show you what's happening right now, it gives you a complete historical record. You can actually go back and see past events, like this degraded status from back on June 25th, and you can click in to get all the details on what happened. That kind of historical context is absolutely priceless when you're trying to troubleshoot a problem.
Okay, so let's wrap this up and put a bow on it. Think of Azure Monitor as your central command. It's collecting all this critical data for you. You've got metrics, which are the raw numbers. They tell you what is happening. Then you've got logs, which are like the text records. They give you the story, the why it's happening. Insights and dashboards are there to help you see it all visually so you can make sense of it. And the final piece of the puzzle is alerts, which let you be proactive. They'll ping you the second something needs your attention.
So there you have it. You've built a system, you know how to test it, and now you have this amazing suite of tools to monitor its performance and its health. But that just leads to the next big question, right? Because being able to see a problem is great, but what if you could automate the response? What if the system could start to fix itself? Now that's an interesting thought.
Hey everyone, in this video we'll go through the very last lab, Unit 3 Monitor and Load Balancer resource using Azure Monitor. So let's click that option, and then here you can see that our overall picture here. So first let's talk about what is Azure Monitor. Azure Monitor provides features and tools for collecting, managing and analyzing IT data from all of our Azure resource. We can also monitor other cloud or and on-premises resources. Two things are important, like metrics and logs. So metrics are a quantitative measurement that shows snapshots of application or resource performance. And matrices are typically numeric values that you can measure over time. And logs are textual records or events, actions, and messages that occur in a resource applications. So Azure has got like Azure Monitor Insights, which actually visualize and give a dashboard options to consume and transmit monitoring information about like all the applications relate to that one. So in this task, we are going to create a fast virtual network or VNet. Then after that, when you create a VNet, there will be subnet, and underneath you are going to create all the VMs into backend pool, because we are going to use load balancer. Then we are going to create a like log analytics workspace. Then we'll use functional dependency views, and we'll view the detailed metrics and configure diagnostic settings. There is the number of tasks. So I will put this link so that you can follow when you do your labs. So let's start the hands-on now. So the very first thing that we are going to do is create a virtual network. So for that, you need to connect to Microsoft Azure portal. Here I have already connected to Microsoft Azure portal. Then search for VNet or virtual network. If you type VNet, it will come virtual network. So select that option. Then click on create to create a VNet. Select the subscription. Then for resource group, select your resource group. In this case, I'm going to create a new. So click create new. Give a resource group name. Click OK. Then click give a VNet name. Then select the region. In this case, we are going to select West US. West US 2. So let me. Then click Next. It will go to Security tab. So here we are going to use Azure Bastion. So you see that here is the Azure Bastion. So select that Enable Options. Then we need to give that Bastion host name. We are giving a name, my Bastion host. Then here Azure Bastion public IP address. Select a creative public IP address. Give a public IP address name. Now we are not enabling any other security options for now. So click Next. In IP address sections, let's replace this VNet IP address range. So we are going to give, for our lab perspective, 10.10.1.0.0/16. Delete the default subnet and add a subnet. We're going to give that for this is for backend, so backend subnet. .1.0/ we are going for default subnet range is 10.1.0.0 to 10.1.255.255, and that is size is 24. So that is fine. Click Add, and we have Azure Bastion subnet, which is 10.1.1.0 to 10.1.163, because that is 26 range, so 64 addresses. So now click on Review plus Create. After that, validation passed, so click on Create button. So deployment is in progress now. So you can see that deployment is complete. Now click on Go to Resource. We can see that VNet is created, and underneath VNet, if we go to Settings, we can see that Bastion is there. Before that, we can select subnet. So we have created 2 subnets, and then we can go to Bastions. If we go to Bastion, we can see that Bastion is there for connecting to VNet, which we did not create yet. So next we are going to create the load balancer, and that will be an internal load balancer. And we are creating here instead of basic load balancer is for later exercise that requires a standard SKU version of the load balancer. So for that, here in the search field, select for load balancer. Then click on create standard load balancer. Here select the subscription, then select the resource group. Then give a load balancer name. Select the region, SQ is standard, and type is internal load balancer, and tier is regional. Next, click on front-end IP configuration. Now we are going to add a front-end IP configuration. So select add a front-end IP configuration. Then give a name here. IP version IPv4 virtual network is selected here, and we are going to select the subnet. Subnet is my backend subnet, and assignment is dynamic here. Click save button. So we are not giving anything for now, so click, we're just creating only load balancer, so we will add all those letters on. So click review plus create and click on create button to create a load balancer. So deployment is complete. Click go to resource. So we are in a load balancer landing page. So under settings, we are going to add backend pool. So select backend pools, and then here click on add. Give a backend pool name. Virtual network is selected already. Backend pool configuration, select NIC. So this will add after creating all those VMs here. IP configuration, we will select that backend resources. So just create only a empty backend pool. So click save. So deployment succeeded. So backend pool section is created. Now we'll go with the health prop. So click on health prop section. Click add. Give a health prop name. Protocol type is HTTP. Port is 80. Path is a slash, and that is 15 seconds interval. Then click on save. So we have successfully completed or set up health prop. Then we are going to create a load balancing rules. So click add. Give a load balancing rule name. Give a front-end IP address. Give a backend pool. Protocol TCP. Port is 80. Also backend port we are using 80. Health prop that we created earlier. Session persistence, we are not selecting that one. Then ideal timeout, we're giving, you see that minutes wise, giving 15 minutes. And we are not enabling TCP reset or floating IP. So now click on save. So save load balancing rules. So far we have configured front-end IP, backend pool, health prop, load balancing rules. Now we are going to set up backend server. So for that, click on Cloud Shell. We'll do that through PowerShell. So here, Cloud Shell type, we are using PowerShell there. Then select no storage amount account required, and subscription, select the subscription and click apply. So this is going to set up a terminal session for PowerShell. Clear this screen. So we need to upload few files. So for that, you see that manage files section. So drop down and then click upload all files. All files exercise. This is M08, and we are going to select Azure deploy.json and Azure deploy.parameter.json. Click open. Successfully uploaded two files. So now we are going to deploy ARM template to create virtual network subnet and VMs which are required for this lab. So let's type the command. We are passing this as group name, and then here we are passing the template file and template parameter file we have downloaded or uploaded here. So press enter. I'm getting a message that cannot retrieve the dynamic parameters for the CMD let, cannot find the path. Let me resolve the issue and then get back. I see that the file here is, maybe I took the wrong file name because that has got azure.deploy.parameter.json. So let me go back, manage files, upload. So Azure deploy, and we need this file, Azure deploy.parameter.json. So I took the wrong file. So click that and open. So let me execute the command again. So we have to give a password. So I'll be back when these VMs are ready. So we see that VMs are created. So let me refresh the page into console. You can say 3 VMs are created now. So now we'll add these VMs to the backend pool. So for that, let's go to Load Balancer, and under the settings, you see that backend pool. Select that backend pool. And here, Nick, if you type add, you can see those 3 VMs here. So select all 3 and then click add. But for our testing purpose, we are going to add 2 VMs, VM1 and VM2, as per lab perspective. So let me don't add VM3, because we are going to use this for load balancer, to test the load balancer. Otherwise, we have to create another VM and then see the load balancer among 3 VMs. So let's use this too and click save. So deployment is in progress. So under backend pool, we got VM1 and VM2. Now to test the load balancer, let's go to VM3. Let's open a new page. duplicate this page. Search for VM or virtual machine. Select VM3. And click on connect. Connect via Bastion. Our username is test user and the password is and click on connect. Pop-up block. So click allow. Network, click yes. PC to be discovered. So then it's coming Suburb Manager. Try Windows Admin Center and Azure Arc today. So we are not just cross that button. Click that Internet Explorer icon. You get a message. So select that OK. To set up Internet Explorer 11 dialog box here. Now let's go back to Load Balancer. Select that front-end IP. Press enter. You can see it's going to my VM1. It's going to my VM2. So we can see that responses come from two backend server, VM1 and VM2. So now after that, we'll go next task, which is create a log analytics workspace. So for that, let's minimize this VM. Here, search for log analytics. Log. So you can see that log analytics workspace. Select that option. Then click on create. Under basic tab, select the resource group, select subscription, then select resource group. Give a name for log analytics workspace. Select the region. We are not giving any tag, so you can just click into review plus create. Validation is in progress. When validation passed, click on create button to create this log analytics workspace. So deployment is complete. Click go to resource. And you can see that log analytic workspace is created now. So let's go back home. So next task, we are going to use functional dependency view. So for here, and then go to load balancer resource. Expand monitoring section and select insights. So you can see that there are different options available. So select the show metric pane. Let's see. So you can see that a few key matrices are already there. Health probe, backend pull metrics. If you cross that one, you can see that there's another option is view detail metrics. Click that options. So you can see here you are getting more informations here. Load, load balancer data throughput, overview help options there also. You can see that load balancer. So click that front and back end availability. And if you go down, we can see health probe status here. We don't see that much data because we have just created now. But normally you will see a point here. And if you get value lower than 100 for these items, that indicates that there may be an outage of some kind of those resources. Then you can go to data throughput. You can get different types of data related to data throughput data. Inbound, outbound. And there is a flow distribution. This is for if you look here, so this is for flow distribution for VM flow creation and network traffic. So now let's go back to home. Select monitor. And on left side, you can see that there is the option service health. Click that one. And here also you're getting different options to see like service issues, health advisors, plant maintenance. So different options are available that you can work on based on your requirements. If I go to resource health, under resource health section, click that resource health options. And here, under your subscription, you can also select for resource type. So let's select for load balancer. So here we can see that load balancer status. Select that load balancer. And from here, you can get also like health history informations. So So two options there that add here resource health alert and diagnostic and solve problems. And if we click here just to see learn more about, you can check that one also. Now we'll configure a diagnostic settings in our next task. So for that, let's go back to home and then select the resource group and check for our load balancer that we created. And under monitoring, you can see the diagnostic settings. So select the diagnostic settings and then create a add diagnostic settings. Give a name here. Under all matrices, select send logs to analytics workspace, and this is the workspace that we created. We also select that matrix, all matrix, and select the subscription and workspace where it will go to. So when that is done, click on save button. Fail to let me resolve this issue. So what the message that I say that with my subscription, no, I'm not registered to use Microsoft Insight, but this is the last portion of the task. So if you go here, this is the one that how to set up a diagnostic. So you know how to do that one. Because of my lab resource limitation, I cannot proceed or I cannot click, like it will not work for me, but you know how to do that one. And that's actually completes our lab, and it's always better to remove your services or resources into your lab environment to avoid incur cost. So if you have any questions, please add into comment sections. Otherwise, I'll see you in maybe in different lab. Thank you.